Okay, well, welcome to, well, maybe. Oh, okay, welcome to Comp 422 and Comp 620. Sorry for the reminder. The survey is due by tomorrow at noon. If you have not done the survey, be sure you get it done. It's worth 100 points. You'll lose 100. We don't want to lose 100 points. They're so easy to get. Otherwise, yeah, it'll be hard to get it back later on. Also, tomorrow is the last day to drop. If you don't drop by 5 p.m. tomorrow, well, then you're in the class. Now, of course, you can drop later on, but it will show up in your transcript as having dropped a class. If you drop, you can also change sections, add classes until tomorrow. So you want to rearrange your schedule, you can do that until tomorrow. Then it's stuck. You're in the class. Now, of course, you drop them, can't add, but you could drop classes after that until sometime in October, but it will show up in your transcript as having dropped the course. All right, okay, today we want to do a little bit on the formalization of what security is. That's about all the formalization we'll do is today. Talk about access control and how it's implemented in several systems, Unix, Linux, Microsoft. Okay. It's some definitions. What is secure? What do you mean by secure? Well, a system is secure if it does what you want and doesn't do what you don't want. You can also, of course, say a system is correct if it does what you want and doesn't do what you don't want. So you want it to be secure, meaning you want it to do things, you don't want it to do things, let other people do things that you don't want them to do. That would be secure. That's clear, but not very well defined for trying to define a system as doing what you want. So we'll use a little mathematical formalism to try to explain this. It's in the textbook. It's also here. Okay, we've got two states. We have all the states your program can enter. Now, what is a state? You can think of a state as a concatenation of all the variables in the program, all the bits. That's state. If you change variable, you go to a different state. You think of all the bits together, one great big integer number, and that's the state of the system. You can change states. So you have the states and all the states the program can get into. Now, some variables, if you have a for loop where I goes from 0 to 9, well, then there's a range only from 0 to 9, but other numbers can have almost any value. So all the possible states. Some of those states are secure. Some of those states, things are working the way they should. The system is secure. And then there's all the possible states. You can think of the system as secure. The system is secure if all the states that you can be in are all good states, all secure states. So here we have all the secure states in yellow, and the blue, actually green states are the ones that you can possibly get to. So any state you can get to is good. That's a secure state. They call it precisely secure, in the textbook, is where they match. In other words, every state that the program can get into is a secure state, and there are no states that you can't get to that are secure. So your program exactly matches all the things that are secure. You also have the possibility, though, where all the states the program can get into is different than all the states that are secure. There are some states your program can get into that are not secure. So again, secure is when all the states the program can be are secure states. Every state that your program, everything your program can do is some secure activity. And there's nothing your program can do that isn't secure. You have a security problem when there are things your program can do. If your program can do something and end up doing something that isn't a secure activity, that would be a non-secure state. Now, can you prove that system is secure? Can you go out and check your program and say, yes, this will always be secure? Can you write a program, an antivirus or some program checker to go out there and check your program to make sure it always stays in a secure state? Sadly, the answer is no. That problem is undecidable. An undecidable problem doesn't mean it's just a hard problem. It means you cannot write a program to do that. There are a bunch of undecidable problems that you cannot write a computer algorithm to solve. These are not things like how many angels can dance in that IC. This is real programs that you can't solve. The halting problem is the one they usually tell you in the computer security course, or excuse me, computer theory course. The halting problem is one where you can't tell if a program will ever stop, if it will ever come to an end, whether it ever returns from the beginning. You can't tell, and there's some interesting proof of that. There are several others non-computer problems. Let me go over some of the really interesting ones. There's what's known as the post-correspondence problem. Imagine you have a bunch of these dominoes. They've got numbers on the top and numbers on the bottom. To make things simple, we'll just use binary numbers. And imagine, again, you have a whole big pile of the yellow ones, a big pile of the green ones, a big pile of the blue ones, and you can use them multiple times. The question is, can you arrange a string of the dominoes such that all the numbers on the top read across are the same as the numbers on the bottom? Here's an example. For that set of 300, if you look at the top, it goes 1001100, and on the bottom it goes 1001100. And in fact, then all the digits on the bottom are the same as the digits on the top. This is a pretty simple problem. A little weird, but the question is, can you write a program to solve that? The answer is no. You can't write a program to solve that, interestingly enough. Here's a slightly more difficult problem. If we look back, the blue one has 2 zeros in the bottom. Here, we'll change it so there's only 1 0 on the bottom. Really simple. There is a solution for this, but you have to put 75 dominoes together to get a solution. It's a rather long solution. So if you were trying to solve this and you were trying to guess one possible thing, you think, oh, I'll just try guessing all the possible combinations if the computers are fast. Well, if you did 74 dominoes together, it wouldn't work. But how would you know you're done? You have to go all 75 and know you're done. And since there's every time you put a domino down, there's several other opportunities. So there's a huge number of possible combinations. How do you know you've got one that works? Question is, and people have proved this, no, there is no solution. And in fact, there are sets of 3 dominoes with three or less digits on them, and people don't know whether they have a solution or not. They haven't figured it out. It's hard. It's easy to prove that it exists by showing, yes, if you put all these dominoes together, it works. It's hard to prove that there isn't a solution. There's another problem that I spent a lot of time with some graduate students on called Wang tiles. The problem is real simple. Imagine you have, again, a bunch of these tiles. They have colors on the edge, and you have a whole bunch. You have a whole bunch of the first one, a whole bunch of the second one, as many as you want. And the question is, can you put them together so without rotating and without flipping them over, so that the colors, and you put 2 tiles together, the colors match? So if you have a red on the top, you have to have, so if this one's going to be above, can be above this one because this one's red on the top and that one's red on the bottom, or this one's red on the bottom, it can be on top of that one. But this one's got blue on the right, it can't be on the left of this one because it wouldn't match. So this one's pretty simple. Yes, there is a solution. And in fact, in these dark lines that you might be able to see there, barely, that is a rectangular, and all the colors on the left and right are the same, top and bottom are the same, so that can be repeated infinitely. So yes. So that's, turns out that's an unsolvable problem. You can't find a solution to that. Here's a real simple problem. We're not going to do this because you can try it sometime. The question is, if you start with the characters MI, can you convert it to MU by using any of the following 4 rules? If it ends in I, like it does, you can add a U. So it becomes MI becomes MIU. Or if you have M followed by anything, you can duplicate it. So the MIU can become MIUIU, or MI can become MII. And then if there's 3 I's in it someplace, you can take them out and replace them with U. That seems pretty simple. This is the mu puzzle. It comes from a book called Gödel Escher Bach, An Eternal Golden Braid. Just took it from him. It's an interesting book, kind of big. You'll learn more about computer science theory, but the book never mentions computers in it at all. It's mostly a discussion between Achilles and a tortoise. It's kind of weird. Gödel, mentioned him in a second. Escher draws these strange prints, and Bach, everybody did music a couple hundred years ago. And they read together. Anyway, it's interesting. You can't get there. You can prove that you can't do it by the number of eyes. How many eyes are there? Well, eyes always are divisible by 3. So, and you can prove that you've got to keep a number of eyes that are divisible by 3. And since 0 eyes is divisible, it can't be done. So, important thing here. So, what about this problem? You can't do it by trying all possible combinations, just like the Wang tiles or the other problem, post correspondence. You can't do it by just trying all possible. You have to step out and look at the problem and think about it. You have to jump out of the system to get it to work. You can't just do it by trying combinations. It won't work. So what it is, it's an unsolvable problem. You can't prove it. The world of computing gets even worse than that. This fellow Gödel, back in 1933, demonstrated that in any complete set of axioms and math theorems and stuff, that there turns out to be truths you cannot prove and falsehoods that you cannot prove. That this always occurs, that there are truths you can't prove and falsehoods that you can't prove. I just wondering about that. Read Gödel, Escher, Bach. He explains it in a very complete way. And you get to the end and go, who thunk it? But yes, and that fun, yes, ma'am. Formal systems, the mu problem is a formal system. It's got well-defined rules of what you can do and what you can't do. In mathematics, we have well-defined rules of what you can do and what you can't do. You want to prove something, yeah, you take a math course and you got to prove whether you can do this or you can't. That's a well-defined system. Well, you can tell the geometry instructor that there are problems, there are truths that you can't prove, and likewise there are falsehoods that can't be proved to be false. Yes. Yeah, it's good. You know, you might think it's false. You can't prove it's false. In other words, like in math class, you do proofs. You're looking at this problem. You can't write a proof for it, but in fact, it isn't true. Yeah. Yes. Right. There is no proof, and there cannot be a proof. Yeah. So, I mean, before this, people thought, well, yeah. In fact, some of the big mathematicians were writing this big book, Principia Mathematica, and they were going to prove everything. They were starting off with real simple stuff, and they were going to prove all of mathematics. And they get down and they were going to do it until this guy came up and said, you can't do that. And yeah, that kind of took the wind out of their sails. So, yes. So, what that tells you is there exist things out there in the world of computing that you can't solve. You can't even prove that they're true or whether they're not true. Well, it would be unusual. Yes, there are. You can look this guy up. You know, Google him, or there are. In fact, I have a little booklet. That, got a little paperback on proof. It's a 90-page book on the proof, but it's not that difficult. It explains. Oh, that's how it works. Gödel, Escher, Bach also explains how it works. Okay, so what it tells you, big thing is you can't write an antivirus or a security program that will look at your program and decide that yes, it's going to be secure, or no, it's going to cause problems. Now, sometimes, many cases you can. There are many instances of the problems that you can solve, but you can't solve all of them. So you can't write a program that in general will check all of them. So we're stuck with students having to take this class and figure it out for themselves. I mean, let's face it, we'd be out of a job if that program was out there. So, but that's not, so we have to go out there and keep the world safe ourselves. All right, I want to talk about access control a little bit. By the way, for those who are worried about, will this be on the test? No, all the stuff about non-computability will not be on this, but there's one thing you need to know that, no, you can't make a program that will test another program to see if it's always going to be secure. That can't be done. Okay, access control. can do a little formalism here, but imagine we have a set of subjects. Subjects are people. People are subjects that you're going to do something. You can also have programs or processes that are subjects, because sometimes you have processes out there running by themselves, taking action, maybe on your behalf, maybe on the system's behalf, doing things. And so they're taking actions. You have to make sure that they're secure. If you ever go out and look, like on my PC, there's 61 processes running right now. You think that PowerPoint's the only thing running? No, there are other programs the system starts up, all running. And they need to be controlled. What can they do to make it secure? And then there are objects in the system. There are objects or files or memory or networks, things that they can access. And some subjects may or may not be able to access some of these objects. Like some users can access a file and some users cannot access that file. Also, some of the objects can be processed or programs. Some users can access this program and some cannot. Easy way to represent this is with a matrix, access control matrix. So on the rows here, we've got subjects. I just have people, my favorite characters, Alice and Bob. And again, you look in the textbook, any textbook on computer security or encryption, they've got these two characters, Alice and Bob, who are out there doing all this stuff. So why be different? All right. So yeah, like file xyz.txt. Well, Alice can read it, she can write it, she owns it. She can read it and she can do these things. Bob can only read the file xyz.txt. He can execute this program, he owns that one. Permissions, basically subjects have permissions on actions they can take on an object. And the usual permissions are read, write, and delete. Those are what you could do to a file or an object. You might take actions on another subject. One subject or one program can access another program, might be able to send it a message or receive a message from it. That might also involve like executing. This program can call that other activity, other program to do something. That would be send it a message or get stuff back or execute. Can you execute this program? Special permission out there is own. If you create an object, you own it. You can transfer ownership to other users, but generally, the owner is usually allowed to give access to that object to other subjects, or other people. So if I create a file, I can give you access to that file or not. I might be able to say you can read it and she can write it. So it might be different. And so those are permissions you can give to it if you're the owner. And again, sometimes you can transfer ownerships or take ownership of an object. Last time we mentioned CIA, the three big goals of computer security: confidentiality, integrity, and availability. I would try to remember those three words. They'll show up all semester. Okay, got to talk about that as far as access. Confidentiality. Okay, here's two formal definitions of that. X is a set of subjects. S is all the subjects and all the people. X is some set of them. That may be the students enrolled in Comp 422. And some information. I is some information in all the world of things that can be out there. So I could be a particular file and all the files out there. I has the property of confidentiality with respect to that group of students if no member of X can attend. So that means there's a file out there, none of the students in Comp 422 can access that file. Or you turn it around and say there's a set of students, subset, and for that information, it's confidential if only that set of students can access that information. So you can't define it to be this group of people or subjects, people, processes can access this object or file. So this group of users can access this file, or this group of users cannot access this file. However you want to define it, get the same thing. One's just the inverse of the other. Integrity is similar. Remember, integrity means you can't change it, basically. So get another set of subjects of the whole universe of subjects, some information out there. You've got integrity with respect to that group of users, if only that group of users can change that file. So you might define a group of students, say TAs in this class. The TAs have integrity. They can modify, the object has integrity if only the TAs can modify it, and the other students cannot modify it. on, another X can have group X object integrity if that group can trust I. The trust, we'll talk about trust later on. It gets to be a complex concept, but it's basically what you think it is. Trust means you believe it to be trustworthy. It's circular definition there. It means that you believe it comes from where they say it comes, and the information has not been modified. You can trust it. And then availability is simple. Availability means whenever you want to access it, you can access it. You can break availability if somebody can make it so you cannot access that object when you want to access that object. Typical thing is somebody crashes the system so that legitimate users cannot access the system to do what they're supposed to do. In the Unix world, of course, remember Unix is the parent of Linux, and Linux is just another version of Unix. Unix is out there since the early 70s. Linux came out much later, and it's just a version of Linux that Linus Torvalds generated. Anyway, so think Linux. There are three definitions of people. There are owners, generally people who own, sometimes users, sometimes called users. There's groups. You can form groups in Linux or Unix. In my experience, very rare that people actually form groups, but you can do that. And then there's the world, everybody. World is everyone. Anybody can access the system. If you allow the world read access to this file, everybody who logs in can read it. And then, of course, there's what access can you have. You can read, write, and execute. Execute means it's an executable program. They can run the program. It might be that they can read or write the program. Well, you could read or write it, but you can't execute it. A lot of times you can't execute it because it's not an executable. It's not a program that runs. Yes, you can actually go out and change the access to a file, so like a text file, and say it's executable, but it's not going to go anywhere. All right, so again, there's user, group, and world, and they represented in 3 bits. You've got read, write, execute. If you do a ls command in Linux or Unix, you'll see it looks like this, where you've got this letters, RW and dashes over here, and the file name over there on the right. And so this top one, first is the user RW dash. That means they can read and write it, but they can't execute it. Group can read it, but they can't, and the world can read it, but they can't write it or execute it. Down here on adc.test4.out, the user can read, write, and execute it. The group can read and execute it, and the world can read and execute it. They can't write it. That would be very common. If you make a program, you let other people use it, you let them read and execute it, but they can't write it. And so, in the bottom here, they have a D in the beginning. That means this is a directory, not just a file, but a whole directory. You can change the permissions. So normally when you create a file, it has initial permissions, usually from the parent, but you can change it. The change mod, chmod, changes the access permissions. So you can do that. So you can say it's who, it's like owner, group, others, UGO, or A for all, and read, write, and execute. So you can go like change mod, user, going to allow them read and write to my file. You can add, this one's everybody has read access. Okay, so in this one on the right, you can go, the owner has read and write access. The group and others cannot read, minus means you cannot read, write, or execute, so they have no access to it. Sometimes this is done with 3 octal numbers. Octal numbers are, like if you don't use your thumbs, base 8, the base 10. So you can represent it as 3 bits. There we go. Oh, computer science stuff, folks. Even for those of you I know aren't computer scientists, just go. You can go 0 to 7. 7 is 111, so you have 704. The first octal digit is the user. The middle octal digit is the group, and the rightmost octal digit is the world. So if you change that to binary, it's 7 is 111. That means the user can read, write, and execute. The group can do nothing, 000, and the world can read it, but they cannot write or execute it. Does that make sense? Computer scientists have people who've never done base 8 numbers are going, what? Well, you just count with your fingers. Don't use your thumbs. You get there. Okay. Let's try a question. Okay. Oop, wrong. Where are the holes? Oh, nope. Buttons missing. We'll try to find that. Oh, there they are. Yes. If you're online, you should be seeing it, seeing the question. So why don't you, if you're here in class, earlier we handed out plastic cards. They look like this. Anybody not in the center, you don't have one? Okay. Oh, yeah, right. I only have a couple left over. I will get more. Oh, depends on how old you are. Once upon a time, it only worked if you binary numbers. And so, but then somebody thought, oh, come on, I got advice. Wait till Amazon comes in, we'll get some more cards. Yes, the question was, do most people use the octal digits, or do they use the words? Originally, years and years ago, decades ago, for those with the gray beards, remember, they only worked with the octal numbers. And then somebody thought that was not very user-friendly, and they changed it to be more user-friendly. It works both ways. So if you're using it now, I would recommend using the letters. They're easier to remember. But if you have gray hair like me, I'm probably going to use the numbers. Okay. All right. Stand by. I'm just not real prepared today. Let me get where is that app? Right. It's moved. Oh, there it is. Okay. Come on, phone. Wake up. Wake up. Okay. All right. You hold up your cards with the proper letter up. Okay. And you gotta hold it so I can see it, so the phone can see it. Okay. I'm getting, yeah, it's telling me you can see them. I got to step forward. By the way, you hold them, do not put your fingers over the black in the front, because then it can't tell. All right, I think everybody. All right, most people. Oh, yes, the answer is read. All right. People in class are so much better than people online, because people online thought it was read, write, and execute. That's what. Oh. Wrong question. Where are we? Oh, anyway, I think we'll go back. Okay. I might have had the wrong question up. Sorry. Okay. Well, we're going to figure out the kinks in the system eventually. We'll be doing more of this during the semester. Kind of keeps you on your toes. All right. The answer is read, because everyone, user, group, world is a 4. That's 100. Read, right? It's read. The answer is read. Okay. All right. Now, axis matrix. We showed you that matrix a little while ago with the subjects on the rows, the objects on columns. Most systems don't keep that matrix because it gets to be very big. You know, it's the number of objects times the number of subjects. That's too big to keep. So most of them store it as access control information for the individual object. They have access control lists. Access control lists define for each object who can perform an action on that. So instead of saying you can do capabilities, capability is you say what this user can do. Access control says for an object, who can access this object and how. So the capabilities are the columns, access control the rows. Most of the time you have columns. So you can say for the file xyz.txt, it will go, oh, Alice can read, write, and she's the owner. Bob can read it. If you've got an Android system, you can change the access rights that an application has. In the Android system, applications are same as users. Turns out, in fact, that Android is built on top of Unix and secure Unix. And so, but there's only one person on your phone. You don't have multiple users. You have multiple programs. So instead of having multiple users, it has multiple programs. So Android thinks of the different programs as different users, so you can provide different access rights to different programs. And so you can provide access to different programs. You can say this program, in case this one is allowed to know your location, it is denied access to the storage in the camera. Can't get that. So, when you give it access, you can also specify always have that access, never have that access, only when you're using it. That's only when it's up. And an Android apps can also run in the background. You might not want them to have certain access rights when they're running in the background. You want to only have this access rights when you have that screen in front of you, which is usually the case. You don't want it watching and listening to you in the background. That's generally not good. There's all sorts of things you can get permissions to: cameras, calendars, contacts, storage, SMS, that's text messages, all sorts of things. On an iPhone, Apple's it's very similar. You can provide a list of access rights for a particular app. What can that app have access to? And you can specify what can I have access to your location. What does it currently grant? You can, again, specify how it's to use that access, whether it's to do it, can I have it only when it's running or all the time? Now, when you're installing software on your phone, be careful. Only allow an app to have access to the resources that make sense for the app to have. If it's asking for something, do not grant it that access if you don't want to, you don't think you ought to have access. My favorite example is I downloaded an astronomy app. They're kind of cool. You point them at the sky and it shows you what you see, it puts names by everything. Kind of cool. But it wanted access to my contacts. Why does an astronomy app need access to my contacts? So I just didn't install that one. Get rid of that one. That one's dangerous. Any app that's doing something like that is probably malicious, probably doing things you don't want it to do. So be careful of that sort of stuff. I was going to ask this question. Can you see me? We just had a glitch there. Anybody you can see us now? Did you lose me for a minute?
Yeah, we did.
Yeah, you got knocked out.
Okay, only a short time. All right. Well, we'll keep going then. You can see the screen, I hope. You have to share the
We
screen again.
can't see the slides.
Okay, hang on. We'll work on that. And okay. Sorry, I'll have to talk to our tech people again. I thought we had fixed that. Now, can you see the screen? Anybody want to answer? You can see the slide access control list?
Yes.
Okay, good. Okay, and you don't have to see me. All right, moving on then. Sorry. Computers don't always work well. All right. hopefully people out in the internet can hear and see me. Oh, you don't want to see me, you want to see the slides, right? Oh, that came by. Where the hell am I? Okay. Participants can now see your application. All right, we're hoping that it works. We're hoping it's going to keep working. We have to drag IT in here again. All right. So anyways, that means you can't raise your privilege. It doesn't make any sense to have accesses if you can change them. Nor can you give other people accesses that you don't have. So if you're allowed to read this file but not write it, even you can't give somebody else permission to write it. Owners usually can give the rights away. Okay. Again, programs can be subjects and humans can be subjects, and they can differ. Sometimes you might have a program that you are running, but the program has one set of access rights and you have a different set of access rights. You might not want them to be the same. Imagine, okay, that you have downloaded a program and it needs to do something. You may not want it to access everything that you can access. Get out of here. Okay, you're back. We're going to share again. I'm sorry this keeps happening. I wish I knew what it was. I had the technicians in here fix it. Thought I had it fixed. Okay, you can see the screen? Yes, okay. Again, merging, you have a program that you want to have access rights and the user. You may not want them to have same access rights. And it can get complex. I have a couple of examples here. You might have a data file that a program updates, but you don't want the users just to read and write that file. You want this program to update that file, nothing else. So that program has to have read-write access to that file, but the users, in a sense, don't. And then there's the allocation of rights. You're a manager, you're going on vacation, you want to give your assistant access rights so they can do things where you're gone, but you won't be able to pull them back when you're done. Let's talk about, you mentioned a little bit about Unix. Let's talk about Microsoft. Microsoft has ways to access objects. You can share them. You can give fine details on what users can and cannot see. Microsoft has something called Active Directory. If you're in a network of computers, you might be using the Microsoft Active Directory. But I'm not going to talk about Active Directory because it's long and involved, and it does sort of work. It gives users access. You can have users that are using their PC, that are logged in only to their PC, or they may log into the domain. The domain is the network of computers, an organization of them, and they can have access to the resources of the domain, all the computers on that. You might have printers in the domain, and individual users on the computers have access to those printers or not. Some users may have access to certain printers and other users not, or files, shared files and stuff like that. Generally, when you're using your laptop, you're the only user. There are not other users there, although there are other programs running on your laptop. You might have multiple users running the same computer. Sometimes you use it, sometimes maybe your roommate uses it, sometimes your wife uses it. Heaven forbid should your kids use it, but yeah, you might want to have different access for different people, that they can do things that other people can't. And again, there's background activities they want. So you want to be able to provide access to the different groups, different users. There's principle of least privilege that you'll see throughout the semester. And this is a very important rule for computer security, that you should never give a user or a process more privilege, more capabilities than they need to get their job done. Only give them enough authority that they need to get their job done. Sometimes people make it simple. We'll just give them root authority. We'll let them do everything. That way nothing gets in their way. Well, yes, but then they might be able to do things that you don't want them to do. That happens. I happen to notice a lot in the Unix world, where you get a Unix system and you just log in as root and do all your stuff as root. Well, root can do everything. So you don't have any security problems, nothing gets in your way. But if anything happens, nothing gets in its way to stop it. You know, if if you're running on your laptop, usually people run as administrator. It allows them to install them. But if you don't run as administrator, you have another administrator account there, and you run only as yourself, as a regular user, well then, if some malware gets on your computer while you're running, or something gets downloaded, it's limited in what it can do. It can only do those things that the user can do. It can't do administrative things. So that prevents it from doing a lot of damage. There is something in Microsoft World has assigned access. You can specify that this user can only execute this one program. Now, what good is that? A lot of times you'll have a kiosk, a computer running in a case that shows things for users, might have touch screen, allow them to, that runs with assigned access. It only can run that one program. If somebody manages to get out of that program, only thing they can do is run that one program. All the system will let them do. Run the one program so they can make that access. Try to make it secure. Microsoft has detailed means of controlling the access. They also, of course, understand that your grandmother is running the computer, and they make simple things. They have the concept of sharing. You go up there, do you want to share this file or share this program? You say yes, then everybody can access it. So it's basically everybody or nobody. You can specify the same thing with details. You can specify file properties that what can they do. Let's go over some of this. You have file properties, you go up to the security tab, and for a particular user, and in this case is all users, that all users can, in this case, they can read and execute and read the file. They cannot write it. They can't modify it. That's all they can do to that file. You can, back up. There's a button on here that says advanced. You click that one, you get over to this. It goes into more detail of what you can do. And you can specify the owner. You can, again, take ownership of a file if you have the authority to take ownership of the file, and more detail. Full control, by the way, means you can do everything. You can change permissions. You can go up there and say, oh, I want to edit this. I'm going to specify that the user can have different permissions. Other users can have different permissions to this file. You, again, can't give them permissions that you don't have. You can take away permissions. You can say, no, they cannot read this file. Even if you can read it, you can say they can't read it. But you can't say, if you're only allowed to read it but not write it, you can't let them write it. That doesn't work. When you create a file, by default, it inherits the permissions from the directory in which the file resides. So if the file is in a particular, that directory has permissions and the file gets the permissions out. You can then go back and change it. You can unclick the inherit permissions. There's a button, back there. Yes, way over here, inherit permissions. Click. That means it's going to start off with all permissions, and they always do. But you can unclick that, and it will. And you can copy the permissions or delete them and change it so this particular file has permissions that are not the same as the directory. Groups. Now, to make access easy, you can create groups. You can have a group and say, this is the Comp 620 group. Or this is the faculty group, or this is the TA group for Comp 620. And you can give them permissions. That makes it easier than having to specify each individual user when you want to give permissions. You can just say, yes, this group has this permission. So it makes it a lot easier. So in the Microsoft Windows world, there are a bunch of default groups. There's administrators. Obviously, administrators have administrative privileges. Who else do we have? Performance monitor users. They're allowed to use the performance monitors, debuggers, a couple other things out there, a whole bunch of them that they can do things backup. These are groups. You can give them privileges or not give them privileges. In a network domain, again, if you're on a domain, you can, if you can log into the domain, you can then get privileges from the domain or not. And the domains can have groups. Not only does your computer have groups, but the domain may have groups. So you may say this printer is accessible to this domain group. Or you have an object in your file that you might share to everybody in that domain group or not. Or you can say this local group. So you have people in the local group, people in the domain, and you can add. You can add users to a group. Very simple. There's a add user box. Tells you who the user is, and you can add it. then you can set the permissions, what access they are allowed to have for individual objects. And again, object be a file, printer, network, whatever it is you want. Directories, again, when you're doing that, the default is this object only, but then you can specify, well, this whole, you want to change permissions for this directory and all the files in this directory or not. Now, it gets pretty interesting when you have users who belong to multiple groups, and the different groups have different access rights to an object. And then the system has to merge those access rights to come up with a final access right that defines what that user can do to that object. And there are, of course, well-defined rules for how that works. In the Microsoft world, you've got full control, write, read and execute, read, and deny. Notice that deny is at the top. If you are denied access, then that's it. Doesn't matter what else any other group has, you can't get to it. Deny means you're not allowed to access this object at all. That is different than if nobody specified. In other words, if you belong to a group and it doesn't say whether you can do anything with this object, then basically you can't unless you belong to another group that says you can. So if you are a member of the Comp 620 group, you may be able to read a file. If you're a member of the Comp 620 TAs, who may also be members of the Comp 620 group, the TA group might be able to read the file and write it, modify it. You merge them together. You have, when you have in two groups, if you have two access rights, you always get the highest one, the highest ranking one. So if you're allowed to read and execute and you're allowed to write, by the way, write also can read and execute, then you're allowed to read, write, and execute. Full control, which you can do everything. Deny is the highest rank. Remember that deny is highest. So if you're denied, that's it. Can't get there from here. Okay, let's try another clicker question if this is going to work for me. See if I get luckier than before. Polls. Stop it. I don't want to see what Susan can do. Talking about Fred here. Okay. Okay, that's a problem. Something broke. All right. Hopefully the people online can see the question. What can Fred do? Yes, they can, because some people are answering it. There it is. Think about that here in class. Get your card up. I'll get my app up. Logs into his phone. Okay. Let's see those cards. By the way, as you notice, we just kind of handed out the cards. I don't know who you are. The card on it. I don't know what. Got to show it. Just looking at yourself. That doesn't cut. Yeah. All right. Okay. All right. I hope everybody's had a chance. Let's see. We've got 73% of the people online have answered. We'll end the poll. Look at the results. Full control was very popular. Most people in class did full control. The online people are asleep, I'm telling you. Okay. Yes. Okay. Let's see. Fred is a member of the advertising group, which has write permission. He's also a member of the HR group, which has read. Actually, the answer is C, right. Let's go back, take a look. Oops, come on, finger. Okay. Write is not full control. No, write is different from read. Full control says you can access that. Not only do you have read and write permission, but you can give away permissions. Full control allows you to specify permissions for others. Write, which allows you to read and write. So actually, the answer here is write, because Fred, advertising gives him write permission, HR gives him read and write. So the biggest one, merging them together, is write, so he's allowed to write. Let's try it again. How about Joe here? Okay. Joe, where is Joe's question? Okay. There we are. Okay. Yeah. Try again. All right, hurry up, right, let her up. Okay, I think, yep. Gotcha, all right. Oh, okay. Yeah, almost everybody got this one. The answer is D, read. Joe, because he's a member of that one group, has read permissions. The other one doesn't specify. This means doesn't say yes or no, so he has read permissions. And we'll try one more here. Maybe. Oh, okay, and let's. This is the question we've had before. Oh, hang on. All right, online's got it. Let me see this one. Okay. Got an answer? Maybe. Okay. All right. Oh, we have a mixed decision here. Online people are still, 89% of them participated. All right. D was the most popular answer. Unfortunately, the right answer is A. A bunch of people did answer A. Yes, the answer is A. Why A? Because remember, you have to look at here. County group is denied permission. Deny is the highest priority. If you are denied access to an object, no matter what other group you belong to that has access to it, you can't get there. So, yeah, so you think these engineers are going to allow the accountants to get to their files? Not a chance. Yes, question. Yes, deny means you cannot read, write, or execute this file. You can't do anything to it. It's not, you can't use this object. And that is the highest priority. If you're denied, if you belong to a group that is denied, no matter what other group you belong to that allows you access, you're denied. Yes.
First question, we will see because they're part of the advertising group.
Has write is higher than read, write. Read and execute. Write also can read and execute. Right? It should really be there should be really called read, write, and execute. Hey, tell Microsoft they should have called it read, write. Write means you can do all those things. Full control means you can do all those things. Plus, you can change the access, and read and write, you can't go out and change the access rights to it. If you have full control, you can do anything. Deny, you can't do anything. Okay, that's it for today. Remember that tomorrow night is the last time to add a class or drop a class or change sections. If you are enrolled Wednesday, you are enrolled for the semester. You can drop until sometime in October, but it will show up in your transcript as having dropped the course. There is an assignment, the introductory survey. If you haven't done it, we'll get out there and do it. It's a 100-point survey. You're going to really wish you did, because there's an assignment coming out this week. It's going to be a lot harder than that. Also, note that I don't take attendance in this class, but the registrar requires me tomorrow to specify who's never showed up. I have to say people who have never come to class. Well, how do I know? Particularly those people who watch at night. It's because of the survey. If you don't do the survey, I don't think you're here, and I'll have to report to the registrar as not ever coming course class. Okay, so please do it. Question? Oh, keep those. And if you don't have one of the plastic ones, I'm going to try to buy more plastic ones, and we'll get that too. Okay. Thank you. I want them at the end of the semester. Unless they're the paper ones, you can keep those forever. And turn off the recording. Okay, online. That's it. Any questions?
Nope.
I have
Oh,
a question.
yes.
I have two actually. So I completed the survey, but when I went back in, it looks like as if I didn't. So how can we confirm that we actually were counted for the survey?
Oh, okay. I haven't graded the survey yet. It's all, everybody's gonna get 100 if you did it, 0 if you didn't. Yeah, and Blackboard doesn't handle the concept of not having a score. So I had to give it right and wrong answers. And it's very hard to give a right answer for your name. So you probably have the wrong answer for your name. But yeah, everybody gets 100. I happen to know, Ms. Royster, that you did it. I saw you.
Okay,
Okay.
thank you. And second question is, for this class, or I guess for the entire program of cybersecurity, do you recommend Windows or Mac?
Whatever you like.
Okay.
Yeah, it's a personal preference. They all work. I use Windows because I've used Windows for many decades and
Mhm.
I know it. Windows allows you a little bit more lower level access. And being an old computer guy, I kind of like that low level access. On the other hand, I think the Apple systems are easier to use. It's up to you, whatever you like, whatever you can get a good deal on.
Okay. All right. Thank you.
Sure. Anybody else out there?
Yeah, I have a question.
Mr. Dickens?
Will this recording be posted to Blackboard?
Yes, I think we got the recording the whole time now. We didn't lose
Oh.
it. Cool.
No.
In fact, it's still recording. Uh-oh.
That's
Everything
it.
you said has been recorded. We know you. Okay. Anything else? Well, in that case, I'll turn off the recording and bid you adieu.